Most people, when they talk about a telescope, they expect to use their eye and look through it at objects in the sky. A radio telescope is very different from that. The primary focus of our research and my research group is to understand how solar flares work in the sun. When the sun produces a solar flare, that flare has many impacts on us here on Earth. The particles that are accelerated in the flare can escape from the sun and come directly to Earth. That can affect spacecraft, can even affect people flying over the poles in polar aircraft routes. And so we want to understand the initiation of the solar flare, the very thing that starts it off. A lot of the effects that are most dangerous to us and our technological systems on Earth are in fact not visible in ordinary light or in other wavelengths that we had available. The radio emission is providing us with a way to see what was invisible, but yet extremely important. When we designed EOBS, we were able to make an instrument that specifically for observing the sun can handle all of the challenges that observing the sun hands us. The actual telescope is made of all of these individual antennas, which are spread over a couple of kilometers, more than a mile across. So each of these small telescopes is acting to create one large telescope. The frequency range of the Owens Valley is 2.5 to 18 gigahertz, so that's quite a wide range of radio frequencies. And so to convert those radio wave measurements into knowledge about the particles requires modeling and theory. So what we have done is develop a modeling framework where we can actually create a three-dimensional picture of what's going on in the flare. By making those things visible and allowing us to make the measurements of the environment there, we're able to deduce not only that the flare is occurring, but how important is it going to be in terms of its effects at Earth. All of our technological systems can be impacted by particles and by magnetic fields from the sun. And those effects are sort of lumped together into this term space weather. One of the things that EOBS does is to look at these space weather events and improve our ability to nowcast not only whether they're underway, but how impactful they will be, how strong the effects may be at Earth. We're hoping that that can lead eventually to forecasting, reliable forecasting, where we're actually able to not only say that it's occurring now, but how likely a future event is to occur. Our data are actually used across the world, so many outside users are anxious to get our data and do their own research with it, combine it with other kinds of data from NASA spacecraft and other ground-based instruments. What it can do already is really fantastic, but what we envision is something of order hundreds of antennas that will be able to do 100 times what EOBS can do in terms of science.